All right, everybody, welcome back. I'm going to make a video for 8.4 determinants. So we're going to start out by taking a step further from what we did the previous day. Our objectives for 8.4 are use a formula to find inverse of 2 by 2s. The formula we're going to employ this year is use your calculator from the inverse like we did yesterday, or do it by hand. Either way, we're not going to learn any shortcut techniques this year. Find the determinant of 2 by 2, new lesson for today. We're not going to do the minors and cofactors, and you can see that's crossed out. And we're going to find determinants of other square matrices. 2 by 2s and 3 by 3s is what we're going to be focusing on this year. So first up, a determinant is a value. Determinant is a value of a matrix and will be denoted by the absolute value bars that you see around A. That's telling us to find a value. It may be positive or it may be negative, but we're going to find a value. Okay? Now, how do we do it? They first of all put the bars around the outside to represent, hey, find the determinant. They've labeled the points A, B, C, and D. And then what we're going to do is we're going to take the A and the D, kind of this little diagonal here, minus the B and the C, kind of that diagonal right there. So with this example here, you can see that the A is the 3 and the D is the 10. So 3 multiplied by 10, minus sign between. The 5 multiplied by the 7, 30 minus 35 for a negative 5. And that is the value of the determinant. Notice it's negative. It's very possible that that can happen. Okay? We're not doing the shortcut, so we can flip this to the next page. Now, 3 by 3s. There's going to be two methods to find determinants of 3 by 3s. The first method is going to be called expansion by minors. This method is going to be used later on in the year, second semester, when we do vectors. So let's first of all see how this is going to work. Very similar to how we did multiplication using the highlighters. I'm going to first put the yellow highlighter on row 1 because we're going to use row 1 most often. It's just easiest to do row 1. Then I'm going to put the second highlighter, the column, on column 1. You can see that the 1 is intersected. It is highlighted on both. That is what our minor is going to be. So here's how we start this out. We equal it to the one that's overlapped, which is a 1. And then what we do is we're basically crossing out the row and the column that contain it. So we can see that's left over not highlighted is going to be 5, the 6, the 8, and the 9. Put the determinant bars around it, and now we've taken it from a 3 by 3 to a 2 by 2. Next, we're going to go to the middle. We're going to move the blue highlighter over. You can see that the 2 is the one that's being intersected, crossing out the row and the column that contain it. We now have a 2 as our minor on the outside with the 4, the 6, the 7, and the 9 left over. Now we move it one more time to the right. We can see that the 3 is what's highlighted. That will be our minor. And then we can create the 4, 5, 7, and 8 2 by 2 determinant matrix. Pause for a second, let the computer catch up. Now, also down here below, you can see this little scheme. Now, you can see it as a 3 by 3 on the left and a 4 by 4 on the right. We're not going to be working with the 4 by 4 this year. But what we have to know is that depending on how we do this, because you can choose any row or column you want, there's an underlying sign scheme that goes with it. I just like choosing row 1 because oftentimes it's easiest. And you can see right here that we have a plus minus plus. Well, I can't see on this screen if anything is happening. I feel like our recording is paused. We're just going to stop. Oh, hey, it is caught up. I see it on the screen now. So we will keep going. All right. So the plus minus plus, as you can see right here, it depends on whatever row or column. Using row 1, we're going to have a plus, then a minus, and then another plus. Okay, and you can see they're filling in a little bit faster now. So now we go ahead and apply the rules from the previous page, in which we're going to do AD minus BC. So we're going to have 1 multiplied by 45 minus 48. minus a 2 multiplied by 36 minus 42, and then plus a 3 multiplied by 32 minus 35. 1 multiplied by a negative 3, negative 2 multiplied by a negative 6, and positive 3 multiplied by a negative 3, giving us a negative 3, a positive 12, and a negative 9. Add them all together, and we end up with a final value for this matrix that I created of 0. Now, they don't all equal 0. This is just one randomly selected because I just counted from 1 to 9, and it became 0. That is expansion by minors. So we took the 3 by 3 down to a 2 by 2, and we expanded it. You can see I crossed out minor. The only thing we need to know about it is it's whatever number we choose. Cofactor, not worrying about it. And now we're going to learn a second method for computing 3 by 3 determinants. This is the diagonal method. Some people might really like this. Okay? It's kind of neat how it works out. It's kind of contrived and made up, but it works. And I've got the process written here in blue. You can see it, first of all, says to rewrite columns 1 and 2 at the end. So we'll do that. 1, 4, and 7. The 2, the 5, and the 8. Write it down. Then it says multiply diagonally upward. So we start in the bottom left, and we multiply going upward. 7 times 5 times 3. 35 times 3. 105. We write that number directly above that arrow. We then multiply 8 times 6 times 1. 48. And then one more multiplication going up because we run out of diagonals with 3 in them. 9 times 4 times 2 for 72. We add those numbers together, and we get a grand total, because it says here in 3, add numbers together, a grand total of 225. I like to circle it out. So we've done that going upwards. Now, we're going to do that same process. Number 4, repeat 2 and 3 going downward. So 1 times 9 times 5 is 45. 2 times 6 times 7, 84. And 3 times 4 times 8, 96. We add those 3 values together, and we get 225 also. Now, the last piece is number 5, bottom minus top. So we're going to take the bottom, we're going to subtract the top. So that's going to be the green, 225. Minus the top, 225, and we get, crazily enough, 0. It was the same problem from before, but we have now confirmed with 2 different methods that the value of the determinant is 0. Okay? All right. Now, take a second and give this one a try. Now would be a great time to pause the video and try it as I put down the numbers and come up with an answer. Okay, I've done the work appropriately. Now we will do the last piece, the bottom minus the top. 226 minus negative 176. Notice it's going to turn positive in this case, and we're going to end up with a value of 402. So that was the diagonal method. Could we have done minors? We could have. Now, let me show you one more piece. We did a little bit with the calculator yesterday. Let's pull up the calculator and let's show how to calculate the value of the determinant. Second, in matrix, we need to right arrow over to the edit feature, and we need to make sure that we have a 3 by 3. Now remember, calculators might be different depending on which model you have and how it's going to look here. So our matrix is 8, 0, negative 1, 8, enter, 0, enter, negative 1, enter. Row 2, 1, 7, 11, 1, enter, 7, enter, 11, and enter. And then a 0, enter, and negative 2, and enter, and a 4 with an enter. Okay? Checking our screen, everything matches. We now quit out of here. Now, to find the value of the determinant, second matrix, but right arrow to math, and then look at choice number 1, determinant. So we'll put determinant on the screen. We will do second matrix again, and we'll go and grab matrix A, and we will end up with a value of 402. The same value that we computed by hand, we can verify it on the calculator. Okay? Minimize the calculator. Go to the next page for me. I had some 4x4s on here, but we're not going to do 4x4s this year, so I figured, hey, let's modify one more and give it a try. And you can try whatever method you want to. I figured, I don't know. Should we do minors? We just did diagonals. Let's do minors on this one and see what happens. Let's do the expansion by minors. Okay, so equals 3, because I'm going to use the 3, cross out the row in the column, giving us the minors with the determinant 2, 0, 0, and 6. Close it. We know because we're using row 1, we need a minus because that is the rule. You have to memorize that that is the rule from that scheme above. Let's erase this little piece here. Let's now circle the 0, cross out the row and the column that it contains, and it's going to give us minus 0, multiplied by 1, 0, 4, and 6. Close it, plus, come back over here, grab the eraser, circle the 2. Cross out the row and the column, 2, multiplied by 1, 2, 4, and 0. So now we can go ahead and do our computation of the minors. 3 multiplied by AB, which is 12 minus 0, minus 0. And now you're kind of looking at this like, well, if there's a 0 in front, it doesn't matter what's on the inside. And you're very right, because that's going to be 6 minus 0 plus 2 multiplied by 0 minus 8. So multiplying it out, 36 minus 0 plus 16. Grand total on this one. Uh-oh. Noble made a mistake. Negative 8, changing our sign right here to a negative, giving us a grand total 20. Which we could type this into our calculator and verify that this is actually going to be the value, but I think I'm pretty confident with the 20. Okay, lastly, not on your paper, but on my paper, I figured, you know what, why don't we do an application with a determinant since we're not actually going to compute a 4x4. So here's our example. Make sure you write this on your paper. I'll pause for a second to give you a chance to write it down. You can see that we have the determinant of x minus 2, negative 1, negative 3, and x, and it has to equal 0. So we're telling you the value of the determinant, but we're not telling you the numbers within the determinant. So we apply the same methodology. We're going to do AD minus BC. X multiplied by x minus 2 minus, don't forget it's always minus between negative 3 times negative 1. And that must equal 0. A little bit of distribution. That's a negative 3 times a negative 1. That's a positive 3. So it's going to be a minus 3 And now we've got a quadratic. And from our quadratic, we can now turn it into x minus 3 multiplied by x plus 1 equal to 0. Extend just a touch, and that will tell us that our two values that we could get to make this determinant equal 0 are 3 and negative 1. Okay? So that's our basic notes. The problems from 8.4 will follow along the same way. Hopefully this video helps out, and we will see you back the next time.